Have you ever looked up at the night sky, gazing at the endless expanse of stars, planets, and darkness, and wondered, what is space actually made of? To the naked eye, it seems like a vast, empty void, a place so silent, so distant, and so unchanging that it feels more like a concept than a tangible reality. Yet the truth is far more fascinating and complex than most of us imagine. Space, contrary to what we might think, is not truly empty. It is a vast and intricate tapestry, woven with visible and invisible threads, particles, forces, and phenomena that defy our understanding. It's the ultimate paradox, a realm of emptiness that is, in fact, brimming with secrets. Today, we're diving into this cosmic enigma to uncover what really lies beyond the blue skies of Earth. Let's start with the most obvious, the stars and planets. These luminous giants and rocky worlds make up only a small fraction of what space is made of. But they are the part we can see, the tangible, awe-inspiring markers of the universe's grand scale. Stars, composed primarily of hydrogen and helium, serve as the universe's powerhouses, creating light, heat, and the very elements that make life possible. Planets, on the other hand, are the resting places of these elements, offering a home for life, or the promise of it, amidst the cosmic chaos. But the visible matter, the stars, planets, and galaxies, represents less than 5% of the universe's total composition. The remaining 95% is an uncharted territory of dark matter and dark energy, forces so mysterious that even our most advanced scientific instruments struggle to detect or explain them. Imagine a universe where the majority of what exists cannot be seen, touched, or directly measured. It's like trying to solve a puzzle when 95% of the pieces are invisible, and then there's the so-called emptiness of space, the vast stretches between celestial bodies. While it might seem like a void, space is actually teeming with activity. Tiny particles, known as interstellar dust and gas, drift through the cosmos, shaping the formation of stars and galaxies. Even the vacuum of space isn't truly empty. It hums with quantum fluctuations, creating virtual particles that flicker into existence for the briefest moments. The deeper we look into space, the more it challenges our understanding of reality. What we once thought of as a simple absence of matter has proven to be a realm of unimaginable complexity and beauty. Every inch of space holds a story, a trace of the Big Bang, a hint of a star's life cycle, or the whisper of forces we have yet to comprehend. In this video, we'll unravel these layers of mystery and dive into the very fabric of the cosmos. From the visible wonders of stars and galaxies to the invisible enigmas of dark matter and quantum particles, we're about to discover that space is not just a backdrop to the universe, it is the universe. So, buckle up, because what we're about to explore will forever change the way you see the night sky. Stay tuned, because the universe is waiting to reveal its secrets. When we think of space, the first image that often comes to mind is an infinite, empty black void, silent, cold, and lifeless. But appearances can be deceiving. Space is far from being a true vacuum. It's a dynamic and intricate environment filled with unseen components that make it far more fascinating than it seems. Let's break it down to understand what lies beyond the surface. Contrary to common belief, space isn't entirely empty. While it's true that the density of matter in space is incredibly low compared to what we experience on Earth, space is still filled with a surprising variety of materials and forces. Imagine standing in a vast desert. It might look barren from a distance, but closer inspection reveals grains of sand, traces of life, and even the occasional oasis. Similarly, space is teeming with activity when we know where to look. At the heart of this activity are the most abundant elements in the universe, hydrogen and helium. These tiny particles make up most of the visible matter in space. In the vast interstellar regions between stars, clouds of hydrogen and helium atoms drift silently. These particles might be sparse, measuring just a few atoms per cubic meter, but they are essential, Over billions of years, they clump together to form stars, planets, and everything else we can see. Hydrogen is particularly fascinating. As the simplest and lightest element, it serves as the universe's foundational building block. Helium, born in the fiery hearts of stars or during the Big Bang itself, is its close companion. Together, these elements form the gas clouds that serve as cosmic nurseries for new stars. Now, let's move to the more mysterious components of space: dark matter and dark energy. Together, these make up an astonishing 95% of the universe's total composition, yet we cannot see or touch them. Dark matter is like the invisible scaffolding of the universe. It doesn't emit light or energy, making it undetectable with ordinary instruments, but its gravitational pull is unmistakable. Without it, galaxies would fly apart. Dark energy, on the other hand, is even more elusive. This force is responsible for the accelerated expansion of the universe. Think of it as a cosmic wind pushing galaxies farther apart at ever-increasing speeds. These invisible phenomena challenge our understanding of physics and remind us that the universe is far stranger than we can imagine. To truly visualize space's complexity, let's take a journey between the stars. Here, space is filled with interstellar gas and dust, microscopic particles that might seem insignificant but play a crucial role in the life cycle of stars. These clouds, called nebulae, are not just empty spaces. They are the birthplaces of stars and planets. Imagine using simple animations to show this process. Start with a sparse cloud of hydrogen and helium particles floating aimlessly. Gradually, these particles are drawn together by gravity, forming a dense, glowing region. Over time, the gas ignites, giving birth to a new star. Animations like these help us visualize how space, though appearing empty, is constantly shaping and reshaping the universe. When we gaze at the night sky, what captures our attention most are the brilliant lights scattered across the darkness, the stars. But the visible components of space go far beyond stars. Space is a rich mosaic of fascinating celestial objects, each playing a unique role in shaping the universe. Let's dive into what we can see and how these components tell the story of our cosmic origins. Stars are the most prominent feature of the night sky and the cornerstone of the visible universe. These massive balls of hydrogen and helium burn brightly, producing the light and heat that sustain life in their surrounding systems. Every star has a story. Some are young and vibrant, glowing fiercely in their early stages of life. Others are aging giants on the brink of dramatic transformations, such as supernovas. A few are remnants of ancient stars, like white dwarfs or neutron stars whispering tales of the past. Stars are more than just luminous points in the sky. They are the forges where elements heavier than hydrogen and helium are created, making them the source of the building blocks of planets and life itself. Orbiting stars are planets, the rocky or gaseous bodies that vary dramatically in size, composition, and atmosphere. While some, like Earth, harbor life in complex ecosystems, others remain mysterious, uninhabited worlds with extreme conditions. Gas giants like Jupiter and Saturn dominate with their size and stormy atmospheres. Rocky planets like Mars and Venus tease us with the possibility of hidden secrets beneath their surfaces. Each planet, whether within our solar system or far away in exoplanetary systems, adds to the diversity of space's visible elements. Comets, the icy wanderers of the universe, carry the ancient materials from which our solar system was formed. With their long, glowing tails and elliptical orbits, they are like messengers from the past, revealing clues about the early days of the cosmos. When these celestial travelers approach a star, the heat causes their icy surfaces to sublimate, creating the magnificent tails that make comets some of the most breathtaking sights in the night sky. Nebulae are the colorful clouds of gas and dust scattered throughout the galaxy. They might look like cosmic artwork, but they are much more than that. They are the birthplaces of stars. Emission nebulae, like the Orion Nebula, glow with light as their gas is energized by nearby stars. Reflection nebulae shine by reflecting the light of neighboring celestial bodies. Dark nebulae, although less visible, contain dense materials that will eventually form new stars. Nebulae are living proof that the universe is constantly evolving and creating. While dust might seem insignificant, cosmic dust plays a vital role in shaping the universe. These tiny particles, often no larger than a grain of sand, drift through space, forming the foundation for many celestial phenomena. Dust gathers in nebulae, acting as the seeds for star and planet formation. It absorbs and scatters light, creating the spectacular colors we associate with some of the universe's most stunning sights. Here's a fascinating fact. Cosmic dust doesn't just create stars and planets, it also carries the organic compounds necessary for life. Scientists believe that the dust that formed Earth also contained the ingredients for life as we know it. Here's a mind-blowing idea. The same cosmic dust that floats silently through the universe may have been essential to the creation of life on Earth. These tiny particles are rich in carbon and other organic molecules, which, when combined with the right conditions, can lead to the formation of complex compounds like amino acids, the building blocks of life. This means that every time you look up at the stars, you're not just seeing the past of the universe, you might also be glimpsing the origins of life itself. Our universe is an unfathomably vast and mysterious place. While we've uncovered many secrets, the majority of the cosmos remains hidden, literally. Beyond the stars, planets, and galaxies lies an unseen realm that makes up 95% of the universe: dark matter and dark energy. These enigmatic forces challenge our understanding of the universe and open doors to questions we may not yet know how to ask. Dark matter is one of the universe's greatest puzzles. It makes up about 27% of the cosmos, yet we cannot see, touch, or detect it directly. So, how do we know it exists? Scientists have discovered dark matter's presence through its gravitational effects. Galaxies rotate faster than they should based on the visible matter within them. Something unseen, dark matter, is providing the extra gravitational pull needed to hold them together. Why is it called dark matter? The term dark doesn't mean it's evil or mysterious, though it is mysterious. It simply means it doesn't emit or reflect light, making it invisible to telescopes. What could it be? Dark matter might consist of undiscovered particles that interact with the universe in ways we don't yet understand. Here's a thought-provoking question. What if dark matter holds secrets about the fundamental nature of the universe that could completely change how we see reality? Even more elusive than dark matter is dark energy, a force that makes up 68% of the universe and drives its accelerated expansion. Imagine the universe as a balloon and dark energy as the mysterious force inflating it faster and faster. The discovery of dark energy was a surprise. In the 1990s, scientists expected the universe's expansion to be slowing down due to gravity. Instead, they found that galaxies are moving away from each other at an accelerating pace. This shocking revelation led to the concept of dark energy. How does it work? Dark energy counteracts gravity, pushing galaxies apart. Why is it so mysterious? Unlike dark matter, which reveals itself through gravity, dark energy remains entirely theoretical. Scientists know it's there, but its true nature is still unknown. This leads us to another question. What if understanding dark energy unlocks the key to controlling forces we can barely comprehend today? Together, dark matter and dark energy dominate the universe. 5% of the universe is visible matter, everything we see and touch. 27% is dark matter holding galaxies together. 68% is dark energy, pulling the universe apart. This delicate balance shapes the cosmos. Dark matter gives structure, ensuring galaxies don't scatter, while dark energy drives expansion, preventing everything from collapsing. The mysteries of dark matter and dark energy spark endless curiosity and debate. Here are some open-ended questions to reflect on. What if dark matter contains clues to the origins of the universe? Could it be the key to understanding the Big Bang? Could dark energy someday reverse its effects, causing the universe to shrink instead of expand? Are there other forces or phenomena as mysterious as dark matter and dark energy, yet to be discovered? When we think of a vacuum, we often imagine an absolute void, an empty expanse devoid of matter, energy, or activity. But modern physics paints a much stranger picture. According to quantum mechanics, even the emptiest regions of space teem with activity. The vacuum, far from being barren, is alive with mysteries waiting to be unraveled. At the smallest scales of reality, quantum mechanics reveals that the vacuum isn't empty at all. Instead, it's filled with what scientists call virtual particles. What are virtual particles? Virtual particles are temporary, fleeting particles that spontaneously pop in and out of existence. They don't last long enough to be directly observed, but their effects can be measured. Why do they matter? Even though virtual particles are invisible and short-lived, they influence the physical world. For example, they contribute to the Casimir effect, a tiny but measurable force between two closely spaced objects in a vacuum. They play a role in fundamental processes like particle interactions and force mediation. The existence of virtual particles challenges the idea of nothingness and suggests that even the void is teeming with hidden activity. Another mind-bending concept from quantum mechanics is vacuum energy. What is vacuum energy? Vacuum energy refers to the inherent energy present in empty space, even when all matter and radiation are removed. It arises from the fluctuations of virtual particles and fields. How does it affect the universe? Vacuum energy might seem small on a local scale, but its cumulative effect across the vastness of the universe could explain phenomena like dark energy, which drives the universe's accelerating expansion. A surprising insight. Scientists estimate that if we could harness just a fraction of the vacuum energy in a tiny region of space, it would dwarf all the energy humanity could produce. The vacuum is far from the simple nothing we once imagined. Instead, it's a dynamic and mysterious medium that may hold the key to answering some of the universe's deepest questions. Here's an intriguing idea. What if the vacuum's hidden energy and particles are the foundation of all physical phenomena, linking quantum mechanics and gravity? This question hints at the possibility that the vacuum could bridge the gap between our understanding of the microscopic quantum world and the macroscopic universe governed by gravity. Here's a fascinating perspective. Even the emptiest voids in the cosmos are bursting with activity we don't yet fully understand. The vacuum isn't just a backdrop for the universe. It's an active player in the cosmic drama, shaping the fabric of reality itself.